And this section involves what's referred to as extracting a square root. And so in order to do this, I want to review. Square roots of numbers. Okay, so if I gave you the square root of some number, and I give you a number that is a perfect square, winds up being easy to solve, right? What is the square root of 4? Okay. Is it positive and negative 2 or just 2? How many think it is just the positive 2? Okay, you guys are right. Okay, when you guys did this in algebra, they made it really confusing. Algebra 1, because they talked about the positive and negative roots of a number, right? So if you just look at the number 4 and you ask what are the positive roots and what are the negative roots, okay, they should have presented it some way like this, and it should have said basically to find the positive and negative roots, you're letting that equal x squared, and you're saying what value can you square to get 4? So the positive root of 4 is what? What positive number can you square to get 4? 2. Is there a negative number you can square to get 4? Negative 2. Okay, so if they presented it this way, it wouldn't be as confusing, because when you're dealing with an equation here, when you solve an equation, if 4 is equal to x squared, you would do what's called extract the square root. You would take that equation and you would square root both sides. And when you extract a square root from a variable term like this, so an x squared, you do have to take into consideration the positive and the negative root. So if you have the equation x squared equals 4 and you solve for x, x is equal to plus or minus 2. But if all you're given is just the number completely outside of any kind of equation or form of variable, you're just dealing with the positive root. All right, now, they won't always give you numbers inside square roots that are perfect squares. If they do, it's nice and easy, just write that integer value. But they might give you something that doesn't completely simplify out, something like the square root of 99. Okay. When you're dealing with these and you're simplifying the square root, okay, what you're going to do is you're going to look to remove any factors that are perfect squares. So what factor of 99 is a perfect square? So you're looking at 9 times 11. So the square root of 99 is equivalent to the square root of 9 times the square root of 11. What is the square root of 9? 3. And can the square root of 11 be simplified at all? No. And now, the numbers that remain inside square roots, do they have to be prime numbers? No. They can be what's called composite numbers, or numbers that have factors. They just can't have any perfect square factors. Okay, so if I talk about a perfect square factor, what numbers am I talking about? 4, 9, 16, 25. Okay, and really, if you have those pretty much cover everything, because most of the other larger numbers will just be multiples of them. Okay, so 3 root 11 is what square root of 99 will reduce to. Okay, now, when you guys enter this online, here's the format that you need to enter them. Okay. Always write the numerical part first, okay, and then follow that with SQRT, and then always put whatever's in the square root in parentheses. Okay, so 3 square root 11 is going to be entered online in this form. If you enter it any other way, it's not going to give you credit. And now, if you were to write this on a quiz or a test, okay, and it gives you 0, what do you think you could do? Yeah, just when you get it back or you can view it, just come and let me know. Again, I can override any of those, but I don't want to have to. It would create too much work to try to put in all possible ways that you guys write it. So my preference is, please just enter it this way when you're doing that. All right, what if I did something like this? I want you to see if you can simplify this product. Right, assuming you're doing this by hand, okay, what would you guys think you could do? Okay. Okay, so we can combine this product into one. So we get 6 times 8, which is 48. And then what? Can we look to find any perfect square factors from this? Are there any perfect square factors that you can see are factors of 48? How many see 16? How many see 4? Okay, so take out the 4. Okay. 4 times what is 48? 12, right? So the square root of 4 comes out as a 2. Root 12. Now, are there any perfect square factors in 12? 4 times 3. Okay, so as we build this little factor tree here, right, we get the square root of 4. That comes out as a 2. Root 3. So really what we're looking at is 2 times 2, which is 4. And then the square root of 3. So if we were writing this for SQRT, 3 would be our answer. If you saw 16 to begin with, that's great. If you didn't, you could build from it. It doesn't matter if it takes you a little bit longer because you're working with the smaller prime factors first. That's okay as well. And now there's another way to approach a problem like that if you're doing this by hand, and that is factor your independent factor, or factor each of these numbers independently. So 6 is what? 2 times 3, and 8 is? Now again, let's take out a 4. We know there's a 4 in there, so even though we can go 2 times 2 times 2, if there's a perfect square factor built into one of them, take it out, because that'll be simplified. Okay, and so we know that when we look at the square roots of these, this one's going to come out as a 2. Okay, and then when we multiply these together, it's a pair of numbers being squared, so the square root of 2 squared is going to come out as a 2 as well. So when we're looking at this, we'll have 2 times 2, which is 4, 4 times 4, which is 16. So the square root of 16 comes out as a 4, and then this 3 stays inside. It might be easier to work with your individual factors rather than trying to simplify everything first and then square root it when you have a larger number. All right, see if you can simplify this product, please. Tell me what you guys see on here. Because I know what I see, and what I see is probably different than what you guys see. Okay, so how would you approach this problem? I'm not trying to put you on the spot. I'm actually curious how you guys see this. Would you factor out a 9 and a 2? Okay, so let's say you factor out a 9 and a 2, which is kind of my assumption is what the majority of you might do on this. Because 9 is a perfect square, right? So as you remove that, and then what can you do with 6? You can do 3 and 2 here. So you have this pair of 2's, so that comes out as a 2. You have the square root of 9, that comes out as a 3. So 2 times 3 is 6, and you'll be left with this factor of 3 inside the radical. Does everybody see kind of my thought process in that? Right, there's a little bit easier way if you can see it. Olivia, question on this?
Yeah, I don't understand why you get rid of the 2 2's.
Well, because 2 times 2 is 4.
Yeah.
Because it's a square root is removing repeated multiplication. So 9 is 3 times 3. So you can take a square root of 9 comes out as a 3. Well, 2 times 2 is 4, so the square root of 4 comes out as a 2. So that's how it came out as a 2 and then multiplied by the 3. The other way you can think about it is 2 times 2 is 4. 4 times 9 is 36. The square root of 36 comes out as the 6. And you still have that 3 inside. Lauren?
I think
2 and 3 and then 6 and 3? Yeah, that would still. But then you'll have a square. It winds up being the same thing, right? Okay, so you saw it as 3 times 2 and 6 times 3. All right, so what you would have is you'd have the 12 on the inside. So the 3's, the square root of 3 squared comes out as a 3. And then 2 times 6 would be on the inside. And then you could take out a 4 and a 3. So the square root of 4 comes out as a 2. 2 times 3. Yeah. Mm-hmm. Now, here's, if you can see this, this is the way that I would see this. Now, obviously, like I'm exposed to this way more than you guys are. But we have this 6 sitting right here. Well, what do we know about 18? Yeah. And so if we think of 18 now as 6 times 3 instead of these other breakdowns, so now we're looking at 6 times 6. So the square root of 6 times 6 comes out as a what? Just the 6, and then what's left underneath? 3. So you could do it that way as well. Okay, but just look to break it down. Whatever works for you works for you. You guys aren't always going to do the most efficient way. Although, again, what's the most efficient way for some of you? Calculator. But if you can work on thinking through it like this, it's a process of learning. Again, it develops your brain a little bit rather than just pushing buttons.